Good morning, everyone. I'm Feng Wang from Alibaba. Now I'm leading the open data platform. Sorry. Okay, it works. Okay. Yeah, I'm leading the open data platform at Alibaba Cloud. So today my topic is about the evolution of Apache Flink from real-time data analytics to real-time AI. Okay, I think everyone knows that last year, 2024, is the 10th anniversary of Apache Flink. So firstly, let's recap the journey of Apache Flink in the past years. So Apache Flink originated in 2009. Yeah. So its origin name is Stratosphere, from TU Berlin Technical University of Berlin in Germany. Yeah. So Stratosphere is a research project. Then 5 years later, the core team founded a company named Data Artisan, and then contributed this project to Apache Software Foundation, then renamed it to Flink. Yeah. But another 5 years later, Alibaba acquired Data Artisan, then renamed it to Verica, yeah, the creator of the Flink Forward. Yeah. Then Alibaba began to put tremendous resources into this open source project and the community and drive it into the de facto standard of streaming compute for real-time data analytics in the next years. So even in recent years, the innovation have never stopped in this community. Yeah. So recently we can see a lot of new projects, the new technologies, some innovations in Flink community, such as Flink CDC, which is a real-time data integration tools, and Apache Paimon, yeah, which is a real-time data lake format. So Apache Paimon is originated from Apache Flink community and has been spun off from Apache Flink to be an independent project in Apache Software Foundation. Yeah. So at the beginning of this year, Flink 2.0 was formally released, which is a new start point for Flink community in the next 10 years. Yeah. Okay, from the technical perspective, yeah, I think Flink sits in the very central position of the modern data architecture or data ecosystem. Flink could drive the real-time data streaming from the operational data system to the analytical systems. So Flink could capture the various real-time events from the databases, the messaging queues, then perform the streaming processing on them, then finally sync the result to the data lake, data warehouse. Yeah. After about 1 decade evolution, the whole architecture of Apache Flink has been completely cloud native. Yeah. So it is very easy for the developers to deploy Flink jobs on the cloud environment. Yeah. So actually, most of the cloud vendors have already provided the managing service for Apache Flink to the enterprise customers. Of course, including Alibaba Cloud. Yeah. Okay, let's have a look at another popular data technology, Lakehouse, yeah, or data lake. I think now data lake or lakehouse has already been considered as the new generation of the data architecture or data platform. Yeah. So we can see that more and more customers, global customers, began to move their data analytics from data warehouse to data lake to lakehouse. Yeah. So Databricks, Snowflake, this joint data companies, all of them are promoting their lakehouse product, lakehouse solution. Yeah. However, we can see that most of the workloads or the data applications running on lakehouse still run on offline mode or batch mode, as it's not real time. But from the business requirement side, I think most companies, enterprises, customers also hope to make the real-time data analysis, real-time data processing on lakehouse architecture. Yeah. So how to achieve this target? So I think it's a good idea to bring Apache Flink, this streaming computing technology, into lakehouse architecture, to combine the two cutting-edge technologies together to make an end-to-end real-time solution. Yeah. But now, currently, the mainstream data lake format is Iceberg. Yeah. So Iceberg is very popular, it's very powerful, but unfortunately, it's not designed for real-time because Iceberg is a batch-oriented design. So in order to solve this problem, since 2022, in Flink community, we incubated a new project. Now its name is Apache Paimon. So its original name is Flink Table Store. So it is a purely streaming-oriented design. It is born for real-time data update on lakehouse architecture. So by leveraging the two streaming technology, Apache Flink and Apache Paimon, yeah, we can come up with a new kind of lakehouse architecture, a real-time lakehouse architecture. So we call it streaming lakehouse because it's built on top of the streaming technology. Yeah. So on streaming lakehouse architecture, we can also provide the end-to-end minutes latency real-time data pipeline. Yeah. So okay, let's think about the question about Apache Flink. Why it could be grow to the community grow so fast, adopt so widely, and become the de facto standard of streaming computing engine globally. Yeah. So from my understanding, it's not only because of its excellent technical design and continuous innovation in the community, but also that it really unlocks the value of the real-time data. It really helps the enterprise customer to improve their business efficiency, to make their business decision systems real-time. Yeah. So for example, I think in various of the industries, in most companies, the management team, the marketing team could make their business decision real-time by the real-time BI reporting, BI dashboard, which is continuously updated by Apache Flink. Yeah, for the e-commerce companies, they can build their real-time recommendation systems on top of Apache Flink to push the suitable products to their customers to get more attention, to get more transaction, get more click rate. Yeah. For the financial systems, they can use Apache Flink to detect the fraud, yeah, in real time. Yeah. It tells you there's so many different use cases. Now I want to take Alibaba as an example to demonstrate how Alibaba built its real-time data platform, its stream data platform on top of Apache Flink ecosystem, and make its the grouping, all kinds of business decision systems real-time. Yeah. So actually, Alibaba is not only the biggest contributor for Apache Flink community, yeah, but also it is one of the biggest user for Apache Flink. Yeah. Since 2016, we began to build the Alibaba unified streaming data platform, the real-time data platform on top of Apache Flink. Yeah. We choose Apache Flink as our streaming engine, real-time computing engine. Yeah. So far, I think most of all of the businesses or data applications in Alibaba Group has been already be upgraded from the offline data to real-time data analytics. Yeah. So including the global e-commerce businesses, so Tmall, Taobao, AliExpress, and Lazada, and as well as the global logistic businesses, Hainiao, and online travels, etc. Yeah. all of the business. Yeah. So especially on the I think on the Double 11, you know, this is Alibaba Global Online Shopping Festival. So our streaming data platform, which running on millions of CPU cores, could handle billions of records per second at the peak time. Yeah. So in order to serve or support such huge workloads, yeah, in real time, our Alibaba's streaming computing team, our technical team has already developed an enhanced version of Apache Flink. We call it a Flash engine, yeah, which is 100% capable with Apache Flink, but much faster. This Flash engine was built on top of Apache Flink. Yeah, so the API layer and the distributed runtime framework keep the same with Apache Flink. But the core parts, yeah, including the operators, the built-in functions, and the state backend have been rewritten in C++ with vectorization model. So it is much faster than the Java version, Java runtime open source Apache Flink. Yeah. So in order to let other enterprises, especially for the enterprises on outside Alibaba Group, also could benefit from this this innovation, this cutting-edge streaming technology, we put the whole data platform, the streaming data platform from Alibaba Group to Alibaba Cloud, yeah, provisioning the managed service for Apache Flink. Yeah. This product, we call it a real-time compute for Apache Flink. We can also call it RTC in short. Yeah. So it is a one-stop real-time data platform, including the web SQL IDE, the meta service online debug, yeah, and also it can provide the operational and management tools for Apache Flink jobs on the cloud, yeah, as well as the core Flash engine. Yeah. So far, it has served more than 1,000 customers globally across more than 10 countries and regions. Furthermore, there are about more than 10,000 real-time applications, Flink jobs on top of it, run on it, driving the real-time business decisions for numerous of the industry's customers on Alibaba Cloud. Okay, so I think from the above topics, we can realize that through about one decade evolution, Apache Flink has become the de facto standard of streaming compute for real-time data analytics globally, and has been widely adopted in the world and easy to use it on cloud. And there's a lot of commercial Flink offers or Flink services on cloud. Yeah. But what is the future of Apache Flink? Yeah. Could it just be used for real-time data analytics? I think definitely not. So in my opinion, in the current AI area, Apache Flink could also empower the AI system, AI applications, real-time. Yeah. Okay, I think it is everyone knows that in the current AI world, the computing power, the model algorithm, and the data are the top three factors for the development, for the evolution of AI technology. Yeah, especially for data, our today's topic. Yeah, it is so scaling law is well known to all of us that the model, the AI model will be more powerful with more parameters. So currently we can see all of the AI models have been becoming more and more larger. The model be larger with more and more data as input for training. Yeah, but on the flip side, the public data, public knowledge on the internet are limited. So rather than the data scaling, I think the data quality, the data freshness will play more important roles for AI technology in the future. Yeah. So just now, Mike gave us a very excellent presentation about the value of the data. Yes, the more fresh value, more value of the data, yeah, because of the time. So I think it's definitely right, especially in the AI world now. So imagine that what will happen if the AI system, the AI agent, lack of the real-time data, the fresh data. Yeah. For example, for the customer service chatbots, if they don't have the latest information about the customers, about the orders, about the background of their question, how can they give the customer the right answer? Yeah. If for the recommendation system, if they cannot get the latest behavior, the action or interest of the customers, they cannot push the right things to the customers. Yes. So there's a lot of kinds of these use cases. So from that, we can easily find out that real time is a native characteristic of AI system. Yeah. So in the future, all of the AI application need to be real time, must be real time. Yeah, must provide the real time experience to our customers. Okay, so next let me to illustrate to how Apache Flink could make the current generative AI system real time. So it is a very typical use cases. Yeah. We can take this example is about an airline customer service chatbot. Yeah, it's just an example. Yeah. So imagine that someone flew from China to Singapore for this conference. Yeah. Then after his arrival in the airport, he cannot find his luggage. Then he can ask the airline customer service chatbot that where is my luggage? I cannot find it. So if the AI chatbot have not enough information or latest information about this customer and his tickets, the information about this luggage, this airline, he cannot answer the question, yeah, to the customer. But if we have built a powerful streaming data platform, yeah, behind this AI system, then I think this streaming data platform collect the real-time data from different places and feed it into the AI system to make the AI chatbot updated all the time, and it could give correct answer to the customers. Yeah. So okay. So next, so I think from this example we can understand how Flink could make the generative AI system real time. Yeah, to help the AI system provide the better experience. Yeah, give the correct answer to the customer. Now let's switch to another trending topic in current AI world. Yeah, it is AI agent. Yeah, agentic AI. So recently, various of AI agents have been spring up like mushrooms in the AI world. Yeah. So even if there are so many kinds of different AI agents, but fundamentally, I want to categorize them into two different types. Yeah, the first one, I call it the conversational AI agents. Yeah, which is triggered by the users or the human users. Yeah, the human users could interact with it proactively. Yeah, ask some questions and get some answers. Yeah, from this AI-powered application or agents. Yeah. Such as the AI coding tools and the chat BI and the deep research. I think all of us very familiar with these kinds of agents. Yeah. But there's also another kind of AI agent I want to introduce today. We can call it event-driven AI agents. Yeah. Which is different from the conversational AI agents. It's not triggered by human beings. It's triggered by the systems. Yeah, maybe by some cars, by your mobile phone, by the machines, by some PCs, by some servers. Yeah, yeah, and this kind of agent could driven by the real-time events. Yeah, imitated from the systems, and deliver the comprehensive, the intelligent insights and take some actions in time. Yeah. So it is work. His working model is not proactive. It's proactively. I think it's reactively. Yeah. Such as such as a fraud detection agent, the sentiment analytics agent, the AI ops agent could be considered as the event-driven AI agents. Yeah. Okay, now let's use a concrete use case to illustrate how event-driven AI agent could bring the customers the intelligent insights and some suggestions. Yeah. So I think live streaming selling, everyone are familiar with it. It is a new kind of selling way. Yeah. So in the e-commerce platform, in the e-commerce industries, it has becoming more and more popular. More and more customers want to buy online, buy the products, purchase the product through this way. Yeah. So in the live stream, the audience will send different kinds of messages on the screen. Yeah, including maybe some questions, maybe some comments. Yeah, and the screen will refresh very quickly. Yeah, quite quickly. So I think it's not easy, or it's hard. Maybe not. It's impossible for the live host to catch up over the messages. Yeah, in time, or read over them. So let alone get inspired by the information feedback from the online audience. Yeah. But if we could build a sentiment analytics agent for this system, yeah, then I think the live host could get a real-time comprehensive dashboard, real-time dashboard. So on this dashboard, the live host could not see the traditional statistic report, such as the distribution of the customers, audience, by location, by age, but also he can get a real-time comprehensive report, sentiment analysis report, yeah, such as how many people like his style, dislike his style, or what topics the audience are talking about, and even give him some or give her some suggestions. So by leveraging this new technology, the live host could change his policies dynamically in real time, online, yeah, to get more attention from the audience, to get more deals, get more transactions. Yeah. Okay, I think from the above use cases, everyone can get more information about the event-driven AI agents and what kinds of things, what kinds of values it could bring for us. So next question is how to build it. Yeah, how to build an event-driven AI agent. So apart from the dependency of the core AI models, the MCP protocol, some general tools, yeah, it also needs a very powerful distributed runtime framework. So firstly, it needs a powerful capability for the continuous processing of the large-scale events. Need to collect the events, process it. Yeah. Secondly, it also needs a powerful state measurement or AI memory for it, across multi-different events. Yeah. So last, it also needs a reliability, the fault tolerance. Yeah, because it is an online distributed system. Yeah. So as a successful event-driven data processor, Apache Flink, I think it's the best choice to be the real-time runtime framework for the event-driven AI agent. Yeah. Okay, so in order to build in order to simplify the development of the event-driven AI agent on top of Apache Flink, recently some developers from Alibaba, Confluent, Verica, and LinkedIn has co-initiated a project, open source project named Flink Agents, yeah, in Flink open source community, yeah, which is aimed to establish a runtime agentic AI framework on top of Apache Flink, yeah, especially for the event-driven AI agent. Yeah. So this framework provides both Java and Python APIs for different personas, and also support the static workflow and the React patterns to build an AI agent. Yeah. So by leveraging the rich connectors and the powerful Flink CDC streaming processing capabilities, it is easy for the developer to use a Flink agent to collect and handle the real-time events and deliver real-time insights, suggestions to the customers. Yeah. But keep in mind that Flink is a stateful streaming computing engine. Yeah, stateful means there's a built-in, powerful built-in state backend, state management system in Flink internally, which could be used as the AI memory across the multiple events. Okay, so in the last part of my today's my talk, I also want to share something how to integrate the current powerful AI capabilities, the generative AI power into Apache Flink, to make Flink could also do the real-time semantic analytics for customers. Yeah. So once again, let's begin with a use case, a concrete use case. Yeah. On the e-commerce platform, I think everyone knows that every product needed to undergo the strict moderation before it is being listed. Yeah, because the non-compliant product cannot be sold on the platform. Yeah. So the traditional solution is to write a Flink SQL to join the product publishing stream and the compliance roles table. Yeah, to use a stream join. Then use a keyword match function to check if the product title contains some prohibited keywords. Yeah, I think this is a traditional solution. Essentially, it is a role-based solution. But in current AI area, I think more and more people they prefer to use the intelligent solution. Yeah, the semantic-based solution. So if we can integrate the generative AI capability, the large language model into Apache Flink, then it will be quite convenient for the Flink users to do the real-time semantic analytics. Yeah. So fortunately, in Flink 2.0, there is a new feature named AI function. Yeah, in Flink SQL. Yeah. Which could help the Flink users to call the AI language model services and the vector search in Flink SQL statement. Yeah. Alongside with the traditional SQL data processing. Yeah. So now let's elaborate how to use the new Flink AI feature in traditional Flink SQL. Yeah. So firstly, we could create or define an AI model by Flink SQL with some options. Some options such as the model name, the endpoint, API keys, system prompts. Yeah. The model which are compatible with OpenAI protocol will be supported. Yeah. So then the developer could call the AI model services for real-time streaming inference in the Flink SQL, in traditional Flink SQL. Yeah. Even for the RAG solution, it is also convenient for the developers to do the embeddings, to do the vector search in SQL statement in real-time mode. Yeah. So I think I think apparently the new Flink AI SQL, yeah, could combine the traditional relational algebra and the generative AI capability together at the same time. Yeah. Then help the developers to do the real-time semantic analytics for both structured data and unstructured data. Yeah. So now let's go back to the previous examples. Yeah, we can create, so let's see how to use a new Flink AI solution to solve this same problem in another way. Yeah. So firstly, let's create a model, create a compliance model. Yeah. Then in the Flink SQL, we can use the AI function ML predict to call this compliance model for semantic analytics on the title of the product to check if it is compliant. Yeah. So obviously, this AI-powered semantic-based solution will bring us better result, better experience than the traditional role-based one. Yeah. Even the product without the prohibited keywords on its title, they could also be detected by the AI technology. Yeah. Okay, that's all for my today's talk. So in summary, currently the Apache Flink not only lives on the real-time data analytics, but also thrives on the real-time infrastructures for the current AI system, AI application. So nowadays, most of the AI models can just be trained offline, updated, upgraded in days, in weeks, even months, yeah, very slowly. But I believe that in the future, all of the AI models, or most of the AI models, powerful AI models, could be trained online, for online mode, and could be updated in real-time mode. Yes, AI system could continuously learning as our human beings. Yeah, so at that time, I think Apache Flink as the real-time computing engine will be able to play more significant roles for the AI models, AI system, AI application in the AI world. Thank you.